Hi there. Thanks for joining us on this, a Q&A edition of Space Nuts. Andrew Dunkley here. And coming up, we'll be answering questions about Earth changing places with, another planet in our solar system. Just a hypothetical. We love hypotheticals. We're also going to talk about the Europa Clipper Mission and what it's all about, because it's getting close to launch time. And, well, Brady and his son want to know all about it. We're also going to talk about protoplanets and why they don't turn into stars. And Martin has sent us a very unusual question indeed, and it involves Mars. But it's the production that went into the question that we're so... we just want to share it with you. That's coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Here he is again to solve all of these puzzles as sent in by Space Nuts listeners, Professor Fred Watson, astronomer at large. Hi, Fred.
I'm not sure about the solve word. I think contemplate is a better word.
Contemplate. Peruse.
Yes. Peruse, yes.
Peruse. I love that word. Yes. Yeah. Well, we might as well just go straight into it. And our first question today comes from Carrick, I think.
Hello, Andrew and Professor Fred Watson. This is Carrick calling in from Whangarei in New Zealand. I just had a quick question in terms of a episode I was recently listening to about the moon being tidally locked to the Earth, and it made me had a bit of a hypothetical question. If we were to replace, or somehow were able to get the Earth to replace a position with Venus or even Mercury, I would assume that eventually the Earth would become tidally locked with the sun of sorts. Now, if that was to occur, or even if that wasn't to occur, what would happen with our atmosphere or with our oceans? Would they be slowly sucked off of the Earth and eventually we no longer have any liquid water on the Earth? Or would the Earth essentially boil to the point where that would happen? You know, the water would boil off before the water was sucked off, essentially. Just had a bit of a curiosity in relation to that as a bit of a hypothetical question. Otherwise, hope you have a lovely day or night wherever you are, and keep up the good work. Thank you.
Thanks, Carrick. We're in Australia, mate. So yeah, we're not far away. We're just across the ditch. I think, Carrick, you're going to be horribly disappointed with what will happen, because we are exactly where we need to be at the moment. Any closer, I don't want to think about it. What do you reckon, Fred?
Well, yeah, that's right. Yes, I mean you're right, Andrew. The moving the Earth's exchanging places with either of the inner planets would not be a good outcome, because our atmosphere is so delicately poised to be appropriate for living organisms at our distance from the sun. So you change that, but it's an interesting thought about tidal locking, and Mercury and Venus are kind of quasi-tidally locked to the sun. They're not like the moon is, where it simply faces one side to the Earth. That's the real tidal locking, but they've got very peculiar rotation properties, which are due to basically resonances of this kind, which is what tidal locking, how the process works. And of course, they're both very different worlds from the Earth. Venus, with this horribly thick atmosphere, kind of 90 times the pressure on Earth, and horrible temperature, what's it, 460 degrees Celsius, something like that. You can imagine that swapping places with Venus, because Venus and the Earth might have at some stage been very similar planets. I mean, not now. Hence the name, the Earth's ugly sister, which is the name we usually give to Venus. So the outcomes
it reminds me, some time ago we did talk about Venus and Mars and Earth all at one stage possibly being livable planets.
Yeah,
in their history.
Right. So Venus has interesting attributes. It's highly volcanic. it probably has water vapor in its atmosphere, but it's well vaporized. It's way above boiling point. The atmosphere of Venus is perhaps the most interesting bit because there are, heights above the surface of Venus where the temperature is sort of Earth-like. It's 15 degrees Celsius or so. And there, except it's now 17 degrees Celsius, that's average temperature. Certainly on one day, 2 days last week. But the bottom line is that the Venus's atmosphere, it's not really the bottom line, it's the top line, because that's a place where life may have formed, and we've had a few interesting false alarms recently about the prospects of biomarkers being discovered in Venus's atmosphere. There's nothing certain. It's probably not the case, but that would be your best bet if you were on a planet that was, if you'd evolved on a planet like Venus, your best bet would have been to evolve as an aerial organism in the atmosphere. And so I think swapping the Earth around, we'd be in big trouble. The Earth's oceans will be lost. They'd be vaporized. The atmosphere would not be in good shape. You probably have a runaway greenhouse effect like Venus has got, and it wouldn't be nice at all.
Well, Venus and Earth are around about the same size. The only other stark difference, I suppose, is that Venus rotates in the wrong direction, doesn't it?
Yeah,
or the opposite direction.
That's that sort of resonance that I was talking about. It maybe it was clouded by something else in the early history of the solar system, but it also may just be a phenomenon connected with tidal locking, where you're slowing down the rotation. It's a very slow rotation, and as you said, it's in the wrong direction.
Yeah, so Carrick, not a good idea. Everything you theorised is probably what would happen. Yeah, the oceans would vaporise, runaway greenhouse effect, dogs and cats living together. It just wouldn't be very nice at all. In fact, I think dogs and cats are living together on Earth already. So it's the beginning of the end.
They sort of do in this household, but it's generally a continuous standoff, I'm afraid.
Thanks, Carrick. Lovely to hear from you. And our next question comes from Brady. Hello from the great state of Florida. As we get closer to the Europa Clipper mission, I wanted to learn more about it, like how it will be searching for conditions that could create life. Also, how long it will take to get there and how long until we start getting data. I can't wait to watch the launch in person. I may make the 1.5 hour drive to be at Titusville. Keep up the great work and never quit the dad jokes. Brady. Thank you, Brady. At least someone appreciates them. Europa Clipper. Yeah, we are not getting far away from a launch. I think it's slated for October. The 10th of October 2024 is the launch window.
It is indeed.
So, we're definitely getting ready for that one. And it's exciting because its primary goal is to search for signs of life.
That's right. And just to answer one of Brady's questions, it will go into orbit around Jupiter, planned anyway, on the 11th of April 2030. So we've got a 6-year, rather less than 6-year journey. It's going to be a Falcon Heavy that will launch it, by the way, as well. So,
wow.
Yeah, it's interesting stuff. Now, the question about what it's going to do is rather a lot. It's actually one of the biggest planetary exploration spacecraft that's ever been launched. It's a very sizable piece of kit, a launch mass of about 6 tons, thereabouts. It's full of instruments which are all designed to look at the surface of Europa in great detail and to probe beneath the surface as well. So it's really, as you said, Andrew, its main goals are to investigate the habitability of Europa, whether there could be life there, not whether there is life there, whether there could be life there, and look for landing sites And so, that's one of them. That'll be done from orbit, of course. It's going to sense whether there is liquid water there, which we believe there is underneath the surface, what the chemistry of the materials that we find on Europa is all about, and what the energy requirements are for any chemical reactions to take place. So I'm just quoting from this is actually from the Wikipedia page on Europa. The objectives are, it says, to study, first of all, the ice shell and ocean, confirm the existence and characterize the nature of water within or beneath the ice, and processes of sub-ice ocean exchange. That's an interesting one, how, material exchanges between the ocean itself and the ice, the underneath of the ice layer. Composition, distribution and chemistry of key compounds and the links to ocean composition. And the geology, the characteristics and formation of surface features, including the sites of recent or current activity. Is there tectonic activity in the ice layers of Europa? And so, the instrumentation for doing that, I think there are something like 11 different, it's actually 9 different instruments that will study Europa's interior and ocean and the geology and the chemistry and habitability, the things we've just described there.
I think that's a saxophone, clarinet, trumpet.
As long as there's a guitar on board, I'm quite happy. So look, just running down the list: thermal imaging systems, mapping imaging spectrometer. That's very much, it's what's called hyperspectroscopy. Very much the stock in trade of remote sensing from orbit. Various imaging systems and ultraviolet spectrograph. There's radar. This is something that I like, especially the acronym. The acronym is REASON. REASON, and it's the Radar for Europa Assessment and Sounding, Ocean to Near Surface. There you go.
Bye-bye.
Very nicely done. Interior characterization of Europa using magnetometry, another nice acronym, ICEMAG. There'll be magnetometers on board that will sense the magnetic field of Europa. And that, believe it or not, is one of the key indicators of whether there's an ocean there and whether it's water. And other plasma instrument for magnetic sounding, mass spectrometer for planetary exploration, surface dust analyzer, gravity and radio science. These are using the radio antenna to do other experiments to learn about how the spacecraft moves within Europa's gravitational field. It's going to have 45 flybys of Europa, and we will no doubt learn a lot beyond 2030. So I'm very interested, and I'm delighted that Brady might be able to watch the launch, and hope if he does, he'll call in and tell us. Yeah,
I'm jealous. We don't get to see many of them out of this country, but some parts of the world, it's, you can get along and watch them fairly regularly these days.
And in Florida, that's right.
Yeah, absolutely. This is going to be an exciting mission for all of those reasons. How quickly will it be? Like, it'll take between 5 and 6 years to get there. I guess once it gets into orbit and gets itself organised, and it's going to come in at a fairly close altitude at times, 16 miles, 25 kilometres. How fast will it be able to start sending us telemetry?
I think we'll get that from the word go. We'll start seeing results very, very quickly, I think. From the orbit and perhaps from some of the magnetometry. I think these will all show up interesting results quickly. So there might be really, really spectacular things coming from the Europa Clipper.
Okay, very good. Thanks, Brady. Great to hear from you. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a quick break from the show to tell you about our sponsor, Incogni. And I'll give you a particular URL very soon, because as a Space Nuts listener, you'll get a special deal. In fact, it's a 60% discount on Incogni, exclusive to Space Nuts listeners. Now, what's Incogni all about? Well, and unfortunately, your personal information is a valuable commodity to all sorts of people. And Incogni can help you reduce the risk of getting your personal information stolen and then sold. And it's as simple as giving them permission to do so. By signing up for Incogni, you limit public access to your private information, you reduce the risk of identity theft significantly, and you keep your data from being sold. That's what they're in the business of doing, and they can do it for you. Try to do it by yourself. It will take you months or even years. At a small price, you can get it all done for you and just get that trouble out of your head. So go to incogni.com/spacenuts. That's incogni.com/spacenuts. Click Get the Deal and look at the price plans. Obviously, if you go for an annual plan and pay up front, it'll be a lot cheaper, but you can do individual plans, family and friends plans. It's a very small price to pay for security. Incogni.com/spacenuts. Click on Get the Deal to protect your personal information online. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Okay, another text question, and it comes from Matthew. Hey guys, first of all, I'm a power line worker, so my knowledge is very minimal. Don't know why, but I was lamely explaining the nebula hypothesis to my 11-year-old son. But when I got to protoplanets, he asked me an interesting question. He asked, why don't the protoplanets become stars themselves? I did a bit of digging, and I think it came down to a lack of mass and fuel to achieve nuclear fusion. Is this correct? And are you able to explain this in more detail? Thanks, and appreciate everything you guys do. Matthew Raisin. Thanks, Matthew. I was doing a bit of reading on this, Fred, and protoplanetary disks. One article I read said, they're just theoretical. We don't really know what they are or even if they exist. I thought, hang on a minute. What? But yeah, it does open up the question, doesn't it?
Yes, but you've only to look at what the ALNA telescope array in the Atacama has done. It's imaged many protoplanetary disks. They're definitely a reality. We can even see planets forming inside them. So I think that article might have been very old, or
possibly so.
Yeah. So the protoplanetary disk is the swirling disk of gas and dust, which is in orbit around a newly born star. So the star has collapsed; its gas content has collapsed to form basically a massive compact object. The temperature's gone up enough that nuclear fusion has started, and the radiation pressure of that nuclear fusion stops further collapse. And so you've got effectively a star. That's what keeps the sun going. It's that balance between gravity and radiation. The bottom line, Matthew's absolutely correct. The bottom line is that the stuff in the protoplanetary disk has, a tiny, tiny mass compared with the mass of the star itself. And it's far too small to get to temperatures for its gravity to collapse things to temperature and cause temperatures that are high enough for nuclear fusion. It's just not massive enough. There's not enough energy until you get cold planets forming. By accretion, they stick together by their mutual gravity, and that basically is the story. The remaining dust and gas that isn't used in that process, some of it's blown away by winds from the star. Some of it, some of the gas goes towards the envelopes of gas giant planets like Jupiter, and we've got so we've got a sort of stable solar system like our own. I think Matthew's got it in one. The protoplanets are not big enough. There's an intermediate stage, by the way, called planetesimals. Planetesimals are things, a few hundred meters across, and they group together to build protoplanets, which then group together to build planets. So it's a hierarchical process.
Do gas giants form in these protoplanetary disks? And if so, they are just a step short of becoming a brown dwarf, which is a failed star, I suppose you could say.
That's correct. Yes. So they do form in the protoplanetary disks, but the process that keeps a brown dwarf hot is not nuclear fusion. It's a fission process. It's called deuterium burning, and so these are not they're counted as stars because there is nuclear processes going on in their interior, but it's not the conventional nuclear fusion that runs a star. And they, by definition, they've got to be more than 13 times the mass of Jupiter. So something 13 times Jupiter's mass will turn into a brown dwarf. You're quite right, but it's not a star. But you're quite right. You've essentially pinpointed one aspect of Matthew's question that I missed. So well done.
Didn't mean to, but it just popped into my head as we were going along.
I don't know that any brown dwarfs are known in orbit around a big star. In fact, we were talking in the last episode about Eta Indi A? The Eta Indi system actually contains 2 brown dwarfs. It's a triplet system with a red dwarf and 2 brown dwarfs. So that's as near as you get to brown dwarfs being in orbit around a star.
Fair enough. All right. There you go. Matthew, you were spot on, and you can tell your son that what you told him was correct. Now, our final question comes from a regular who always asks us some interesting questions, but this time he's taken it to a whole new level.
Who knows what question? Lex in the heart of Herman Gorva. Hello, Space Nuts. And here's my latest question. Mars's primordial atmosphere, if it were sort of comparable to the thickness of Earth's present-day atmosphere, roughly how long would it have taken to leak away into outer space? And might any intelligent creatures there have noticed it happening in real time, as it were, within their lifetimes? Oh, and excellent job, Dr. Watson, concealing the whereabouts of the planet Vulcan, which, of course, is hidden within a planetary cloaking device since the unfortunate 2018 discovery. Wow.
Martin, he's set a new level. I don't know if it's up or down, but he's set a whole new level for audio questions. So who knows what we're going to get next. But thank you, Martin, and well done on the production. That was a lot of work went into that. What do you want to know? Mars's atmosphere. If at some stage it was similar to Earth, how long did it take to eke away, vanish? Well, it's not vanished completely, though, has it?
No, that's right, but it's very, very small. Look, it's the answer is, of course, it depends. But in this particular case, I think we can say it's over millions of years. So you've got a process that is a leakage of the atmosphere, and there is actually a spacecraft that's investigating that, MAVEN, Mars Atmosphere and Volatile Evolution mission, which is still active. It's a NASA mission, looking at the leakage of gas from Mars's atmosphere. So we know the sort of rate that's going on now, and so it means you're talking about millions, if not billions, of years for that leakage to take place. It's the main cause is, well, first of all, Mars is not massive enough to hold on to an atmosphere permanently, and you don't have a magnetic field. That means the radiation from the sun is, it reaches the surface. It can essentially damage the atmosphere, and so basically you've got this stripping of the atmosphere by the effect of the sun and the lack of gravity.
It sounds pretty bleak, really.
It's bleak. So if there were species on Mars, would they notice? Yeah, probably. Millions of years would be a slow process, but they'd kind of realize, because they'd have artifacts from previous eras, that things were changing. And so what they might have done is cast an eye on the next planet in towards the sun and thought that looks like a better bet and headed that way.
Yeah, that's probably why we're here, Fred.
Could be why we're here, yeah.
I think that was portrayed in a movie once, that we were actually seeded here by Martians who left the planet because it was dying because it got hit by an asteroid. But good. What was that, Red Planet, I think it was called, or Mission to Mars? I can't remember which. They both came out around the same time, but both great films. Did we finish answering Martin's question? Yes, it would happen over millions of years, and yes, people probably, if they were there, would have noticed. And taken off for Earth if they could have.
Yes,
which we might have to do one day. We're still around.
If we're still around, we might. That's correct.
And I dare say that by then we may well have the technology to do so.
Who knows?
Yes. Thank you, Martin. Great question. And again, congratulations on the production. One more thing, Fred, before we go. A joke from Misty West, one of our regular listeners and one of our administrators on Facebook. Eating too much cake is the sin of gluttony. However, eating too much pie is okay because the sin of pie is always 0. That's clever.
Yes, it's
clever.
nice.
Too clever for me. But yeah. Thank you, Misty. Fred, we're all done. Again, thank you, sir.
It's a pleasure. So I'm just thinking about Mr. Turtle, thinking that's very clever. Thank you, Andrew. And we'll see you next week, I'm sure.
We will indeed. Professor Fred Watson. Unless, we'll keep an eye on that. Martin will tell us. And we'll see you soon. Fred Watson, astronomer at large. And don't forget to visit our website if you haven't done so recently, spacenutspodcast.com, spacenuts.io, where you can deposit your question through the AMA tab or the Send Us Your Questions tab on the right-hand side. And have a look around while you're there. You can subscribe to the Astronomy Daily newsletter. You can visit the shop. We've got a shop, all sorts of bits and bobs in there if you are looking for something different, and plenty more on our website. And don't forget to hit subscribe if you're a YouTube follower. That's just about it. Thanks to Hugh in the studio as always. And from me, Andrew Dunkley, see you on the very next episode of Space Nuts. Until then, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.